So these are the special right triangles where all of our exact values get derived from. Here's the chart that you need to memorize. So this chart can kind of be divided into two portions. This portion on the right comes from the unit circle. So remember, the unit circle has a radius of 1. So if I were to graph my unit circle, this is the point 1, 0. This is the point 0, 1, negative 1, 0, and 0, negative 1. So we'll do these first since I already have it drawn out. So remember that x, y is cosine, sine, and when I'm on the unit circle, it's just cosine, sine. I don't have to worry about r in front of it because my radius is 1. So 1 times anything is itself. So when I'm labeling my unit circle in terms of radians, I always start here. This is 0. This is pi over 2, pi, 3 pi over 2, 2 pi. So at pi over 2, sine is the y value, which is 1. And cosine is the x value, which is 0. At pi, sine is the y value, which is 0. The x value, which is cosine, is negative 1. At 3 pi over 2, sine is the y value, negative 1. Cosine is the x value, 0. And at 2 pi, sine is the y value, 0. Cosine is the x value, 1. In order to do tangent, tangent theta is defined as y over x or sine over cosine. So when I do 1 over 0, I get undefined because I cannot divide by 0. When I do 0 over negative 1, I get 0. Negative 1 over 0, undefined. 0 over 1, 0. So these are what we call, by the way, these numbers here are known as quadrantal angles. And those all come from our unit circle. The other values here are what we are going to call our reference angles, because we're going to use these in future questions as well, or reference angles, and they all come from the special right triangles, which are up here. So in order to use my special right triangles, you have to have them memorized, but I like to just memorize this chart, and then I don't need the triangles, but that's where they are derived from. So once you have this chart memorized, you can find all exact values. But you need to know SOHCAHTOA if you are going to use your special right triangles. So if I'm going to use pi over 6, that's over here. So that means when I'm doing that, this is going to be my opposite, my adjacent, and my hypotenuse. So sine is opposite over hypotenuse, 1/2. Cosine is adjacent over hypotenuse, radical 3 over 2. And tangent is opposite over adjacent, which is 1 over radical 3, or you will see it more commonly referred to as radical 3 over 3, because that's its rationalized form. We do not need to rationalize, but you will typically see it written as rad 3 over 3. So now if I want to go to pi over 4, I'm going to go to my other triangle over here. Here's pi over 4. In this case, it's an isosceles triangle, so it does not matter which one of the angles that you go to use. But I'm going to use this one, which isn't letting me write. So when I go to use this one, my opposite is 1, my adjacent is also going to be 1, and my hypotenuse is going to be radical 2. So sine is opposite over hypotenuse, so it's 1 over radical 2, or more commonly going to be referred to as rad 2 over 2. Cosine is adjacent over hypotenuse, so same thing here, rad 2 over 2. And tangent is opposite over adjacent, 1 over 1, which is 1. So now if I go to my last one, I am going to be using pi over 3. So back to this triangle, I'm going to erase what I have and mark it up again. Pi over 3 is down here, so opposite, adjacent, hypotenuse. So that means that sine is opposite over hypotenuse, which is radical 3 over 2. Cosine is adjacent over hypotenuse, which is 1 over 2. And tangent is opposite over adjacent, radical 3 over 1, or just radical 3. So here is your chart for both your reference angles and your quadrantal angles that need to be memorized. And then from here, we're going to learn about our unit circle, how it's labeled, and how we find all of our other angles using this information. So here is my unit circle. So I'm going to start by labeling my quadrants. This is quadrant 1, which is positive x, positive y. Quadrant 2, negative x, positive y. Quadrant 3, negative x, negative y. And quadrant 4, positive x, negative y. I am on the unit circle, so if you would like, you can label your 1, 0, 0, 1 in those. But I'm going to start with my quadrantal angles. We said that because this is my initial side, this is always 0. Pi over 2, pi, 3 pi over 2, 2 pi. Now, we're going to label all of these. I'm going to start with halfway between 0 and pi over 2. So if you need to do the math of where this comes from, half of pi over 2, we multiply straight across. That gives me pi over 4. So directly in the middle, this angle measure is pi over 4. And then I'm just going to count 1 pi over 4, 2 pi over 4, 3 pi over 4, and so on. So that means 2 pi over 4 is actually up here. We're not going to label it as this, but if I wanted to, 2 pi over 4 then reduces to pi over 2. Then my next one is over here in quadrant 2. It's going to be 3 pi over 4. Then I have 4 pi over 4, which I don't need to label because it reduces to pi. Then I have over here, this is 5 pi over 4. And then over here, well, 6 pi over 4 would be down here. And then I have 7 pi over 4. And then back over here would be 8 pi over 4. So we don't need to label our quadrantal angles because they're just going to continue to reduce. So I'm going to erase those. And we're left with my pi over 4s labeled in. Next, I'm going to count my pi over 6s. So pi over 6 is right here. After 1 pi over 6 comes 2 pi over 6. We'll reduce these later. Then comes 3 pi over 6, which would be up here because 3 pi over 6 would reduce to pi over 2. Then comes 4 pi over 6. Then comes 5 pi over 6. And then over here would be 6 pi over 6, which reduces to pi. Then comes 7 pi over 6. 8 pi over 6. 9 pi over 6 is down here, reduces to 3 pi over 2. Then I have 10 pi over 6, 11 pi over 6, and then of course over here, 12 pi over 6 is going to reduce to 2 pi. So once again, I'm going to erase my quadrantals because those are reduced. Okay, and lastly, I'm going to go to my pi over 3s because 2 pi over 6 is actually going to reduce to pi over 3. So this is now a pi over 3 angle. This 4 pi over 6 is going to reduce to 2 pi over 3. Here's another pi over 3 angle. 8 pi over 6 is going to reduce to 4 pi over 3. And 10 pi over 6 is going to reduce to 5 pi over 3. So now if I erase those reduced angles, what you will notice is that each of my quadrants has a pi over 6, a pi over 4, and a pi over 3. Those are going to be your reference angles. And then once you start to know where certain angles lie, you can then determine exact values of something like sine of 7 pi over 6, because you would know that 7 pi over 6 falls into quadrant 3, has a reference angle of the denominator. That's how you determine your reference angle. So has a reference angle of pi over 6, and so on. So this is where all of my different angles come from. So you can then go one step further and label all of these coordinate points. So like I said, we started with our quadrantals. So my quadrantals are 1, 0, 0, 1, negative 1, 0, 0, negative 1. My angle measures are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Then it doesn't matter what order you want to go in, but if we want to go in the same order that we just did before, I can even color code it the same way. My oranges, okay, were pi over 4s. So pi over 4, 2 pi over 4 would be up here, 3 pi over 4, now I'm at 5 pi over 4, and then 7 pi over 4. Then I can go, my next ones were green. So we had pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And then my other one was blue. Okay. So I had pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So when I started this, I started with my quadrants, right? I said that this was quadrant 1, which was all positive x, positive y. This was quadrant 2, so all negative x, positive y. This is quadrant 3, negative x, negative y. And this is quadrant 4, positive x, negative y. So every one of these points in here is going to have a negative x coordinate. Every one of these is going to have 2 negatives. And every one of these is going to have a negative y coordinate. So if you know your quadrant 1 angles, you know everything. What do I mean by that? So if I know the cosine of pi over 6 and the sine of pi over 6, which remember goes back to this table here. Okay, so if you have these memorized, you're good to go. So the cosine of pi over 6 is radical 3 over 2. The sine of pi over 6 is 1/2. So that means that's this coordinate here, because remember, it's cosine comma sine. So this is radical 3 over 2 comma 1/2. So all of the other green angles, so this one, 5 pi over 6, is going to be negative radical 3 over 2, positive 1/2. 7 pi over 6, negative radical 3 over 2, comma, negative 1/2. 11 pi over 6, radical 3 over 2, comma, negative 1/2. So now I go to my oranges. Pi over 4. So the cosine of pi over 4 and the sine of pi over 4. They are both radical 2 over 2. So Quadrant 1 is just rad 2 over 2, comma, rad 2 over 2. If I go to 3 pi over 4, this is negative rad 2 over 2, comma, rad 2 over 2. 5 pi over 4, negative rad 2 over 2, comma, negative rad 2 over 2. 7 pi over 4, radical 2 over 2, comma, negative radical 2 over 2. And then lastly, if I go to my pi over 3's, cosine of pi over 3 and sine of pi over 3. So the cosine of pi over 3 is 1/2, sine of pi over 3 is rad 3 over 2. So that's my quadrant 1 coordinate, 1/2, comma, rad 3 over 2. In quadrant 2, 2 pi over 3 is going to be negative 1/2, positive rad 3 over 2. Quadrant 3, 4 pi over 3 is negative 1/2, comma, negative radical 3 over 2. And 5 pi over 3 is going to be 1/2, comma, negative rad 3 over 2. So those are all of your angles. Once you know quadrant 1, you know all of them. So it's important to know your reference angles, your chart, and then start to visualize where certain angles go. And I always go off of my quadrantals. So is 7 pi over 6 greater than or less than pi? It's greater than, so it must be quadrant 3. Is 5 pi over 3 greater than or less than 2 pi? Got to be less than, it's in quadrant 4. So you'll start to get better at these the more you practice. But you need to know your quadrants, your chart, your reference angles, and then you can go from there.